So hey guys, welcome back to my channel. Today I'm gonna show you the Hilbert's paradox of the Grand Hotel, which is a very famous paradox. It refined to infinity. So what's the paradox? So you have a hotel, okay? A hotel with an infinite room. This has infinity rooms in it. And a night manager works here. Okay, there's a night manager here. So one night the hotel is fully booked. So there's a new guest that wants to go to the room. Booked a room. So the night manager to think of a way. He tell the guest from room number 1 to move to room number 2. Guest in room number 2 to move to room number 3. Guest in room number 3 to move to room number 4. And this goes on forever. Okay? Each guest moved from room number n to room number n plus 1. Now, this worked for every finite numbers. Like, if there are 40 guests, you just need to move the guest in room n to room number n plus 40, leaving the first 40 rooms for the new upcoming guests. But now let's see let's say there is a bus with infinite numbers of passengers. So what does he do now? So the thing here is infinity. So he can't put the guest in room number n to room number n plus infinity. That would be impossible. So he tells the guest from room number 1 to move to room number 2. Guest in room number 2 to move to room number 4. Guest in room number 3 to move to room number 6. 4 to move to number 8. And this goes on forever. Okay? So each guest moves from room number n to room number 2n, or n times 2, leaving only the even numbers of room filled and the odd numbers of room empty for the new guests. So those numbers are 1, 3, 5, 7, blah blah blah, everything so on. Okay? So this worked for just one bus of infinity rooms. Okay? So let's say you have an infinite numbers of bus with an infinite numbers of travelers want to booked for a room. So this troubled the manager for a bit. Then he thinked of a way. He remembered that there is a way. There are infinite numbers of prime number, because there are infinity numbers of normal numbers. So there could be infinite numbers of prime numbers. So he tells the room in room number. So he takes the people from the first prime, the 2, power to their room number. So the person in room number 7 moves to room number 2 to 7 power, which is 128th room. This is really hard to do. Then he tells the people from the bus to the next prime, the 3. So depending on their seat number, if the seat number of the person is 7, move to room number 2000. I think it's 2128 or something. I think it's that 2128, or like 3 times 3 times 3 times 3 times 3 times 3 times 3. So this is 9, this is 27, this is 81, this is 243, this is 9, 2 to the 1 first, 729, and this is room number 7. This is a 6 with 2. It's 8, and this is room number 2187 room. The second bus takes the next prime number, which is 5. So if a guest on the seat 5, so he goes to room 5 to the power of 5. And then the guest in room number, so on the next bus goes to the 7th, and on the next bus is 11, and 13, 17, and so on till you finish all of them. So the money of the hotel is blooming insanely fast. But this only works for if the lowest level of infinity, which is the countable infinity, which you count like 1, 2, 3, 4, 5, and it goes on forever. If we're talking, this was called, George Cantor called this Aleph Null. Aleph 0, okay? Call it Aleph 0 or Aleph Null. But if we're counting on the uncountable infinity, we take the integers as well. So what does this do? So the integers, the real infinity. So we list out every single number. We list out a number from 2, 7, 8, and then we take the next number, which is 3, and the next one, okay, and then we do this, and to George Cantor diagonal line, do this. 1, take a 1, take a 9, take a 5. Maybe we should write 2 more numbers. Okay, so we list this number, and we count this, and we get this number. So we make a new number. So my rule is to write a 0 here, plus 1 to every number that has a digit 1. So it's going to be 2. Minus 1 to the number 9, which is 8. Minus 1 to number 5, which is 4. Minus 2 to number 6, which is 4. Minus plus 2 to number the fifth number, which is 2. So plus 2, which you have plus 3, we have a 5. This is a new number. It doesn't appear on this. So this cannot be this. So the night manager can only figure this out on Aleph Null. Remember it. It's Aleph Null. It's not any number else. Can't be like the integers, because if you count this, you would have room pi. Pi and e and square root 2. This room might have 3 desserts, because this is pi, this is irrational, this also have 3 desserts. And we count all the integers as well. Now, this is actual infinity. But if the room is potentially infinity, there is no final number. Because if actual infinity, there is a number, and it's just uncomputable. It's unknown. But in potential infinity, the room keeps rising like this, and then it goes up, and goes up, and it goes up forever. It never stops. Okay? That is really nice to know the Hilbert's paradox of the Grand Hotel, because last time I showed you the tournament of the big numbers. Now I show you the biggest number, which is infinity. And actually, this is a number. This is a concept of an unending problem. So that's it for this episode. Hope you enjoyed it, and I'll see you next time. Leave a like and subscribe to my channel. Bye.